Hi, I'm Sean Bazard. I'm a junior, and for my final project, I chose the image quilting option. The goal of image quilting is to start with a small seed image and create a larger resulting image that preserves the same texture while not having any obvious seams or boundaries in it. I also chose the texture transfer extra credit option, which the goal of that is to take a seed texture and apply it to a target image so that it looks like the target is made out of the seed texture. I chose these 5 images to display my effects, and the top right one of the rocks is a photo I took in the Grand Tetons National Park. The first algorithm that I implemented was the random patch quilting. What this does is that it takes random sample squares from the seed image and arranges it in a random grid pattern without any overlap in the target image. And as you can see, it does create a larger image, but there are lots of overlaps and there's no cohesiveness between all the grids. So there's visible boundaries and seams between all the blocks. The second algorithm that I implemented was the overlapping quilting, which places patches that are similar to its neighbors. So whenever you are placing a patch in the grid pattern, there's going to be a tiny bit of overlap. And what I did was that I found a list of best candidates by computing the SSD between the overlapping region of the current output and the overlapping part of every possible patch in the seed image. Instead of doing this by brute force, which would take a while, I used convolution operations to accelerate the process, and as a result, I got a cost image for each of the candidate regions. I randomly selected one of those that had a cost within a given SSD tolerance in order to remove monotony. And what you see is that the hard boundaries still appear, although it's slightly better than before. Next, I implemented seam finding quilting, which does the same setup as the overlap quilting, but then uses the cut.m method in order to find the minimum error cut, which is a path that I'm going to use to make a mask. Basically, what I'm able to do is that I can pick pixels from either the target image or the seed image and figure out which ones I want to keep during the process. What this does is that it blends the boundaries between the overlapping images and smooths out the transfer between patches, and now we don't have any more visible rough boundaries. As you can see, I think the methods gradually get better with each iteration, and I chose this display because I thought it was a very good example of what my methods could do. Next, I implemented texture transfer, which extends image quilting by modifying the patch selection to also preserve the structural appearance of the target image, which takes into account highlights and shadows. I did this by computing 2 SSDs for each patch. The first is overlap, which is how well the patch matches the output of the overlapping regions. And second, a target SSD, which is how well the patch matches the corresponding region of the target image. I computed a cost function for this, and after placement, the patches are blended with the methods with the seam finding quilting. So the first iteration of this code took 15 minutes to run, and obviously that's not sustainable, so I reduced the image sizes and used convolution for computing the SSD to get the runtime down to a bit under 2 minutes. And I also chose good images to demonstrate the effects best. Thank you, and I'm looking forward to seeing everyone else's projects.